Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hello, welcome to Astronomy Live. Tonight, I'm going to be streaming Saturn. Saturn is at opposition, so it's at its closest point, directly opposite the Sun. So this will be the closest we get to see Saturn this year. You can see the rings and the Cassini division. On either side of Saturn, I'm able to see the moons through the eyepiece, and maybe we'll take a look at that a bit later. But for now, let's enjoy Saturn at high magnification. This is with an 11-inch Celestron NexStar GPS telescope with a 2.5x Barlow lens and a Blackmagic Pocket Cinema 4K. If you have any questions, please leave them in the chat, and I'll answer them as best I can. Alright, I tweeted out the link for the live stream, so hopefully more people can join us. Had a little bit of fun setting things up tonight. As I was setting up, I was experimenting with a different camera. An older camera that typically has worked pretty well for me for planets. No, I'm not outside at a car park. I am outside, but I'm just in my yard. But anyway, yeah, this camera unfortunately is completely on the fritz, which is bad news for me. I do still use it as a finder camera for tracking rockets and satellites, and it's given up the ghost pretty much. It's just glitching out really bad. Now, it could be the capture device is the thing that's glitching out, so I'll have to do some experimentation and see. It's an old modified security camera, and it has to use a video capture card to get it into the computer, and well, somewhere along the way, either the cable or the capture card or the camera, something is seriously glitching out. My guess is the camera, because of how it looks. It doesn't look like a dying cable. It doesn't look like a analog noise. It looks like digital glitching, and the camera itself has its own onboard processing that when I turn features off, it seems to get better for a little bit. So again, it makes me think it's probably the camera. But it worked out for the best anyway. I plugged in the Blackmagic. The good old Blackmagic is doing a fantastic job on Saturn tonight. I did crank up the in-camera sharpening on the Blackmagic. That definitely seems to help with the clarity here. It looks great on my end. Of course, streaming's going to do some compression on it a bit, but despite that, I think it's still looking mighty fine. In fact, I'm going to record a clip here on the camera itself for later processing and stacking. I agree, the seeing looks quite nice tonight. Yeah, atmospheric seeing is not too bad. We have some clouds to the northeast. Not too many, just little puffy ones. It was supposed to be much worse, actually, earlier in the evening, according to the forecast, but it really wasn't bad. The thing that really just held me up was the camera issue, but it was silly of me, kind of, to try the other camera. Honestly, I was just trying to see if I could get away with it, because the Blackmagic, it is a fantastic camera, but I don't want to overuse it to the point of abuse. It's quite pricey, and I like to reserve it for special occasions, rocket launches and quick satellite passes where it's not having to run for hours on end. So because I've had to fall back to the Blackmagic, I'm not going to go streaming into the early hours of the morning and make the camera work that hard. It does tend to get quite hot. It does consume a lot of power. Now it's plugged in to mains power, but the camera, when left running like this for a long period of time, will get quite warm. Now I am recording at 1080p actually. This is a 4K camera, but you can set it for 1080p, and actually that works out well for live streaming Saturn tonight, because instead of simply resizing the video, instead what it does is actually go into a crop factor. It only records the inner part of the chip, the 1920 by 1080 pixels in the middle of the chip, basically. So it has the effect of digitally magnifying the image and going to 1080, which is good here, because most of the rest of it is just black, as you can see. You can't see the stars because we're recording Saturn here with a relatively high frame rate I think I've got it on 1/60th of a second right now, exposure, so only the brightest stars are capable of showing up with an exposure this fast. Now, there is an inconvenient dust mote on the Barlow lens, almost right in the middle, so I'm just moving it off of that. It could be on the camera sensor itself as well, but I think it's probably on the Barlow. In either case, just trying to nudge Saturn a little bit in the view, so that when I stack the video I'm recording right now, we don't have a big fat dust mote on Saturn. I should shoot a flat field, but I'm lazy. When it comes to planetary imaging like this, I'm not. I don't invest as much time in trying to get that all perfect the way I do with deep space imaging. Partly because I'm so used to doing satellite tracking, and with ISS, usually I use post-stabilization after recording the video before I upload it, and in doing that, the ISS tends to drift around the view while I'm tracking, and so it doesn't tend to sit on any dust motes anyway. And so that's kind of just made me a bit lazy about such things. Kind of kicking myself that I didn't use Nex Remote tonight, actually, to remote control the scope from the computer, so I have to get up and use the hand controller, so I can't be completely lazy. But it's doing a pretty good job here with tracking. We do have, as I said, a 2.5x Barlow lens on here on top of the 2x crop factor of the camera, for a total focal length increase of 5x. So with a 2.8 meter focal length, we're looking here with quite a long focal length with this telescope. So yeah, basically it's the equivalent of a 14 meter focal length. So imagine a camera lens 14 meters long. That's what we're pointing up at the sky with right now, assuming a 35mm typical SLR camera equivalent. Yeah, they do have a Wi-Fi controller. I don't typically have enough of a need of such a thing to purchase it. Tonight's a bit of a rare exception, honestly. I do such unusual stuff with this telescope, usually rocket and satellite tracking. The Wi-Fi adapter really is superfluous normally. I need that hard line connection for maximum reliability, directly tying the computer to the scope for control. But tonight, just taking it easy, just using the scope in a more typical fashion, I guess you could say. Oh, that's fun. Got a big spider trying to make a web on the front of the telescope. Well, he's actually down by the dew heater cable, but he's strung a web. Very clearly a single line of silk is coming off the front of the scope. He's just strung a bit of a web off the front of the scope there. I'm not so happy about that. I don't want him making a big web over the telescope. And I have to see if I can get him off. I'll be right back. Okay. Mr. Spider can go build a web somewhere else. Not on the front of my telescope. He wants to make me a free Batinoff mask, yeah. What F ratio am I at? Great question. I am... Well, let's see here. Counting the crop factor of the camera. If we count the crop factor of the camera, then I'm at an F ratio of 50. Not counting the crop factor of the camera, just the Barlow lens, I'd be at 25. And all music tonight brought to you by Stellar Drone. Where am I at? This is from Florida. You can really see the Cassini division here quite nicely. Now, Saturn's rings are currently closing. That is to say, every year they're getting closer to edge on right now. So if you compare Saturn's view to the view I had last year, the year before that, you'll notice it's a little bit more closed now, closer to edge on view. And Saturn goes through those cycles on a regular basis. Wi-Fi is good to set the time. Yeah, well, fortunately with the NexStar, this particular NexStar's got onboard GPS, so it automatically sets its time. Ooh, wow, thank you, Snooch. $50 from Snooch. Just some lunch money from Obi-Wan. Snooch, thank you so much. Appreciate it. I think a Waked Warrior is yanking our chain here. Says it's fake. But Mandelbrot's that was asking where the flurfs were, claiming that it's fake. NASA microchip or something. So, you got what you asked for there, Mandelbrot. Thank you, Eric. Appreciate it. Eric Briggs in the chat joining us tonight. Not to be confused with the other Eric Briggs. Can I spot Titan? Yes, I could. Where is Titan right now? Let me check Sky Safari and find out. So the moment of opposition, by the way, according to Sky Safari, will actually be 4:25 a.m. Now, I'm probably not going to be streaming that late into the morning, but just for record keeping. So Titan is down there, okay. Also worth noting, the view here is inverted by the telescope. I have not done anything to correct that, just so that it, quote-unquote, feels normal, I guess. Feels like it normally does with the controls. My controls don't feel reversed on the telescope. But Titan is sort of 1, 2, 3 moons down and to the left, which is actually going to be up and to the left in the real deal view here now. According to Sky Safari, Enceladus is actually in front of Saturn right now, and kind of in the top part, but I don't really see it all that well. I do see Tethys. Tethys is a faint little star just below Saturn. It's real hard to see, but there is a little dot there. Now, we can zoom out, and I can show some of the moons, so we can do that if you guys want. Let's take a quick look. Accidentally. Oh no. Okay, there we go. I don't know if it came up on stream, but I accidentally went to a recorded video of the moon from some time ago that was still sitting on the card. But, alright, we got the zoomed out view. Now let me crank up the exposure and you'll see more of these moons. You can already see one of them down there in the view. My guess is that's Rhea, but there should be a couple more closer to Saturn as well. So let me crank up the exposure here. Okay, so as you can see, we're starting to overexpose Saturn a bit. We need to do that in order to see the moons that are much fainter than Saturn itself. So there's some hot pixels in the view. Now, what distinguishes the hot pixels first and foremost is they don't move at all. So the little dots that are just single pixels that aren't even slightly jiggling at all, those are hot pixels. Those are not moons. The moons are a little bit softer. They take up more pixels, and they do move a little bit as the motors of the telescope are moving to try to track, but they're not perfectly precise. So there's a little bit of motion there just in sitting here, and you can see those moons moving and dancing under the effective atmosphere as well. So up and to the left of Saturn, we have one moon there. That is probably Dione, I believe, up and to the left. And in fact, let me get a marker up here. I'll point them out for you. Oh, yes, it's live, but that's not what I want. That's old. That's not... Okay, here's my old M101 marker. Let's change this. I'm just going to make this an arrow from the supernova streams I did. Okay, so here we go. Alright, so now we got an arrow I can work with here. So, up here. So you guys can see up here we've got what I believe is Dione. Down here we have Rhea. Alright, down here. Okay. Now, right next to Saturn, as I said, is Tethys. Just faintly there. And as I move around, we should be able to get over to Titan. So let me move the view. There we go. There's Titan. Titan is up here. Okay, so that's Saturn's largest moon, Titan. So hopefully one day in the future we will have a robotic probe flying on Titan named Dragonfly. Currently tentatively planned to launch in 2027 for a 2034 landing. So we're still over 10 years away from that, but it would be absolutely incredible. Basically a robotic helicopter on Titan to study the planet and, well, the moon, and search for signs of microbial habitability. Titan actually has more atmospheric pressure than Earth, but you wouldn't want to breathe it necessarily. It's not got so much oxygen, but it's got some methane for you. Nitrogen, methane, atmosphere. And methane lakes. No, I say methane, but hydrocarbons, I should say. But who knows? There could be forms of life that have found a way to use that. Particularly microbial extremophiles. So who knows what we might find there one day. Alright, what do you guys think? Should we go back to Saturn and zoom back in on it? Let's give that a shot. So this is now what I would consider maximum zoom, really. We are at, well, we have a 2.5x Barlow, a 2x crop factor. So nominally that puts us at equivalent of 14 meters focal length. But, more extreme than that, we also have cropped down the sensor even further from a 4K sensor to the equivalent of a 1080 sensor with the same pixel size, but cropped down to the middle 1920 by 1080 pixels. So, basically, that's like doubling it again. So that's like 28 meters, really. In terms of equivalent focal length. If you had a 35mm piece of film in a camera and you were shooting with a lens, you would need a 28-meter lens to be able to get this kind of magnification on that sensor, well, on that piece of film. How many telescopes do I have? Let's see. In terms of main telescopes, I've got two, but I have an 11-inch Schmidt-Cassegrain and an 8-inch Schmidt-Cassegrain. I also have a 4-inch Maxitov Cassegrain. Mostly use that for testing purposes, but sometimes as a portable grab-and-go scope. I also have an 80mm refractor that sometimes rides piggyback on one of the Schmidt-Cassegrains. It's just a simple achromat refractor, but it's good for some wide-angle views when needed. Iapetus should be showing its bright side. Okay. Let's see. Well, where is Iapetus? Oh, it's way out there. Past Rhea. Well, we can go explore that if you want. So yeah, this is my biggest telescope for sure. But I've got some others for other purposes and applications. I still use the 8-inch Schmidt-Cassegrain from time to time, especially for deep space work because it's got a wedge. I can polar align it, and could theoretically put a wedge on this telescope, but I don't have a wedge for this telescope, and lifting it onto a wedge would be some back-breaking work compared to the 8-inch, which is a lot lighter. So for now, the 8-inch does deep space duty, and this scope primarily does planets, moon, satellites, rocket launches. Alright, well, let's take a quick look at Iapetus. Alright, you really put me to work, but I think I found it. Let me double check here. Let's double check here on Sky Safari. Iapetus. Yep. Well, yeah, that's almost certain. That's got to be what that is. It's the only thing it could be. Rhea is still brighter, even with the bright side of Iapetus showing. Iapetus has this very two-face sort of look to it, with one very bright and one very dark side. But even with that bright side showing, it's still quite dark compared to, say, Rhea. So, let's see. So Rhea is up here, and Iapetus is down here. It's this faint star right there. I've got this thing cranked to maximum ISO and maximum exposure length of 1/30th of a second. Had to change the frame rate on the camera just to do that. But yeah, it's there. It's right there. YouTube is gutting it. Compression making it hardly visible. Yeah. Sorry. Nothing I can do about that. I mean, I guess I could try to blow up the view. I don't know how much this is really going to help, but I'll try something here. Give me a second. I really don't know if this is going to even make all that much difference, but okay. There it is, next to the arrow. Can't even see Rhea in the view now, but there's that faint little thing that's dangling around there. It's dancing a bit at this extreme magnification. I mean, I've blown up the image like crazy, so hopefully it's coming through streaming compression now, but it's this faint little thing right there next to the arrow. Yep, okay. Well, that's Iapetus for you. I'm not going to spend too much more time on that. Let's go back to Saturn now. The more interesting visually, at least for this telescope. Is Saturn just west of the moon right now? No. Saturn is quite a bit to the east of the moon. Yeah, Saturn is great to look at in just about any amateur telescope. Even a relatively cheap telescope will show you the rings of Saturn. What kind of details can I get on Jupiter? It's a great question. I really haven't spent much time on Jupiter with this particular telescope yet. We'll see how it goes closer to opposition on Jupiter. Should be able to get some good details on the clouds. Great red spot, and even some of the moons. Kind of kicking myself that I didn't take a little break while I was setting up the telescope and trying to get things going with the camera. There was a Starlink launch this evening, so that's basically 2 launches today for SpaceX out at the Cape. And I probably could have seen it if I just looked to the northeast while I was busy working, but I didn't even think to look up to check for that. But what I do see in the northeast right now is Jupiter coming up. So yeah, I can see Jupiter just starting to come up now. But it's still very low in the sky, but we can slew over there later and just take a quick look. Won't be as good as Saturn from an opposition standpoint, but should still see some good detail on it if it's up high enough. Otherwise, the atmosphere was going to make things mucky. Yeah, the moon's starting to get a little bit low in the southwest for me as well. If you guys want, we can slew over there real quick and take a look at the moon. And just see what we can see with this scope, just for fun. Alright, so we're just slewing the telescope over to the moon now. We'll just take a quick look here. Alright, so once again I need to remind everyone that the view here is inverted. But this is roughly where the Chandrayaan-3 lander made touchdown on the lunar surface, the southern region of the moon. Hey, SMA. Good to see you. So we're just taking a quick look here where the approximate region where the Chandrayaan-3 lander touched down at the lunar south pole. View's inverted here. How about the Pleiades? Yeah, it's not going to see anything with the Pleiades with this camera, really, just the stars themselves. This camera is really optimized for bright objects. If I put my deep space camera on my wide field refractor, maybe you start to see something there. But the Pleiades are quite a large portion of the sky, and this telescope is extremely powerful. The focal length here is insane, and so you would only see a single star at a time. Is it possible to see the lander? Unfortunately not. The only thing that really can are orbiters around the moon. Chandrayaan-2, I believe, has taken a picture of it already. That was a previous mission that they tried to land, but the lander failed, and that's why they made some corrections for this third one. But the orbiter for that mission is still around the moon. So I believe I think India already captured their own lander with the Chandrayaan-2 orbiter, and the US LRO, Lunar Reconnaissance Orbiter, can probably do that if it hasn't already as well. Yeah, there's some aberration, there's some chromatic aberration. To some extent that's going to be from the Barlow lens, to some extent that's going to actually be atmospheric refraction. As the moon gets lower, you actually get chromatic aberration from the atmosphere itself. Yeah, the moon's not close enough for that. The lander's very tiny, and if you do the math with Dawes limit, there's no telescope on Earth, no optical telescope on Earth large enough to be able to resolve even the Apollo lunar landers, let alone a small unmanned Chandrayaan-3 lander. Just move around here to some of my other favorite spots on the moon just for fun. You can really see the turbulence from all the atmosphere here. The moon is, as I said, getting lower in the southwest sky, so the seeing's not as good as it is for Saturn right now. So let's go back up to Saturn now and enjoy that view, since that's the main highlight for the night. That's cool. So, because I did a white balance on the moon, it's changed the white balance on Saturn as well. But I kind of like it. I think it looks more neutral, pretty good. Now, you might have remembered seeing Tethys as a moon of Saturn just below and to the right of it. And notice it's gone now, so it's now officially behind Saturn, I believe. So Saturn has occulted it. So we're able to actually see the moons of Saturn in motion here tonight as we watch it, which is pretty cool. Can still see Rhea at the bottom right of the view. So if I bring the arrow in, Rhea's down here. I don't know how well that's coming across on the stream. It's pretty faint, but it's there. Yeah, I dare not try an IR mod on this camera. I don't know. I don't trust myself with it. It's too expensive. So, I do have, well, the other camera I was going to try to use tonight actually is IR sensitive, and I could throw an IR filter on there, but that camera's glitching out right now, so no good. Got a few frogs piping up in the background there. Brad Wagner, excuse me, thinks it's CGI. Well, let's see about that. Let's see if I can wave for the camera, huh? Might be sarcastic, but this will be fun anyway. Hello, YouTube. Oh, did it not? Oh, you silly capture card. It doesn't like the frame rate. Hang on. Doesn't like the frame rate and it's refusing to come back on me. Come on. Huh. What have I gone and done to it? See? Maybe it was CGI. He lost the image. Okay, pull the cable. Plug cable back in. Should come back. Turn off camera. Turn camera on. You no do. Why you no do? Okay. Turn off capture card. Turn capture card back on. Hello. Okay, there we go. Alright. Let's try this one more time. There's Saturn. Okay. Maybe it's because my Bluetooth is connected on my phone. I don't know. Okay, 1/30th of a second. Alright, now, as I defocus Saturn, now I can wait for the camera. Hello, YouTube. It's a little bit blurry because Saturn's an extended object and not a point light source, but you can see my hand in front of the telescope as I move my hand back in front of that donut. The donut is the shape of the telescope's mirror. It has a central obstruction, so there's a hole in the middle of the mirror actually to let the light pass through to the camera. And like magic, I refocus on Saturn. Alright, back on 60 frames a second. No, I don't make this music. This is music from Stellar Drone, used with permission, and you should check him out. He's really good at setting the mood for space events like this. Oh, has any company ever made a two-eyed telescope? Biggest binoculars ever? There are, and there's bino viewers. There's really not much you're going to get from an amateur telescope that is two telescopes. I mean, I guess you could do it, and I guess it would technically increase the light gathering area. But in terms of benefit for your money, you're probably better off with the bino viewer. Now, bino viewers are really nice. So a bino viewer basically splits the light into two eyepieces. So you get two identical eyepieces, you slap them in the bino viewer, and you put the bino viewer in your sort of monocle of your big telescope. And that provides the light to both your eyes. And you're going to see better details that way. Your brain will have both eyeballs looking at the object then. And ultimately, it does work nice for that. So bino viewers are a really nice tool for visual astronomy. I don't have bino viewers myself, but I have used them at star parties before. They're quite nice. Thoughts on digital telescopes? Well, depends on the digital telescope. So I did a review of a very affordable digital telescope not too long ago. And, well, I'll let that review speak for itself. And that was the Beaver Lab telescope. Now, there are other scopes out there that are in a much higher price bracket from what's it called? Unistellar, that's the word I'm looking for. And there's other scopes in the same kind of price bracket. And these are smart scopes. These are scopes that are designed to be used even if you don't really know much about astronomy, you don't really know much about using a telescope. That the idea is you can set it on a flat table or surface, turn it on, and go. Now, there are smart versions of more conventional telescopes. But these, I think what you're referring to there about digital telescopes is the idea of a telescope that has an integrated camera and basically doesn't have even a slot for an eyepiece. It has got a built-in camera and it takes pictures. And I know people who use these things. They certainly have their uses. I don't find the value in the price point to make sense for me personally. But your mileage may vary. I think they can be very expensive. And for that amount of money, if you've got that amount of budget to play with, you could put together a pretty good conventional amateur telescope with, a camera, an SLR, something like that you could do what we're doing tonight. You could record video of the planets. You could record long exposures of stars. I would encourage people to go that way. However, that does mean that you have to spend time on the learning curve of learning how to use a telescope, how to identify the constellations, bright stars, be able to align the telescope. The way that a scope like this works that I'm using tonight is I told it where two stars are in the sky. I pointed at Arcturus, and I said, you're pointed at Arcturus, and I pointed at Altair, and I said, okay, telescope, you're pointed at Altair. And after I pointed it at those two stars, it could do basic go-to functions. It could locate other objects like Saturn and the Moon on its own. Now, obviously, I can see Saturn and the Moon, and I could just manually move it there, but the go-to functionality is enabled after you align it. So you have to, with a scope like what I've got here with the NexStar 11 GPS, you have to have some idea of what you're doing, of being able to identify at least a few stars. There is a somewhat more beginner-friendly option within the menu system for NexStar telescopes that allows you to align on 3 bright points. You don't have to know what those points are. You don't have to know the names of the stars. It could be even a planet. You just point at 3 bright points you see in the sky, and it will figure it out on its own. I haven't really used that feature. I have no need of it. But it's designed to be more beginner-friendly because you don't have to know your stars. So there are options out there, even with more conventional telescopes, that help soften the learning curve these days. Beyond that, it depends on what you're looking to get out of it. So if you want a really good visual telescope, you can spend a lot less money on a really good Dobsonian and have no tracking or go-to, but have a really nice scope for relatively little money. I mean, I'm talking, $1,000 or less. Or you could spend $3,000 and get a much smaller scope that has less light gathering ability, but has more motorized functions, computer systems, for doing things like we're doing tonight. Automatically tracking Saturn, videoing it, this kind of thing. Now, there's a lot to unpack there. A visual telescope, like a Dobsonian, can be a really fine instrument, but you have to calibrate your expectations. When you see pictures of galaxies and nebulae in magazines, you see them in beautiful color. Your eyes are not sensitive to that color of deep space objects. Our eyes have different types of photoreceptors depending on the amount of light we're receiving. In bright lighting, we can perceive color with the cones of our eyes, but when we're outside at night looking at very dim objects, 2 things come into play. One is we're using our rods, which are not color sensitive, so you don't have color perception of these nebulae and galaxies. And 2, our eyes integrate the light immediately. We don't build the light up in our eyeballs the way a camera does. When I'm taking a 5-minute exposure with the LX200, it's collecting photons for 5 minutes solid before it finally closes the shutter and looks at what it got. With your eye, you get what you get immediately. So you look at a nebula, you look at a galaxy, and if it's too dim to immediately see, you won't see it. So you need big light gathering ability. That's why a Dobsonian is really good. You get a lot of scope for the dollar. So you can get a really big scope for relatively little money. However, you still won't see color, generally speaking. You will see gray to sometimes a greenish tint if you get a really big scope on a really bright object. But I have never really seen color with my eye. That doesn't mean the color's not there, mind you. When I take a picture with the LX200 and the S-Big camera, it's a single-shot color camera, it's actually true color. Those are the real colors. Now, the camera might be more sensitive than our eye. It's without filters on it, it's sensitive beyond visible light into UV and into infrared. But the color is real. It's just that our eyes can't see it at night, even with a telescope, unless, well, basically an amateur telescope. You're not going to be able to get enough light into your eyeball to stimulate your cones and start to perceive it the way you do bright objects. And I mean, even me sitting out here outside at night right now, looking at the lights on my house, I told them to turn red so that I don't mess up my night vision. I can see they're red lights. They're dim, but I can plainly see their color. But what I'm talking about is when you look at a deep space object, you have to really dark adapt. That means you have to let your eyes adjust for minutes and let your eyes adjust to the very dim light, and then you have to use the you have to use the rods of your eyes, not the cones. Your cones, the color perceiving photoreceptors in your eye, are most concentrated in the fovea, in the middle of your eye, in the middle of your vision. Your rods that are more light sensitive but not color sensitive are actually more dense towards your periphery. So the other thing you have to do when you're looking at these deep space objects is to perceive the maximum amount of detail. You actually don't want to look at them directly. You want to use what we call averted vision. You want to avert your gaze slightly, look away from where the object is in the eyepiece slightly, to allow more of the light to hit your rods, and you will actually see better that way for these very dim objects. But as you can imagine, it's a bit of a learned skill, and ultimately it may not be satisfying for everybody, because it's not going to look like it does in the pictures, because you're perceiving what is available instantaneously. The dimmest parts of it might be below your ability to perceive, even with a big 16-inch telescope. But that's not to say you won't see a lot of galaxies and a lot of nebulae, but they are what we call faint fuzzies. They're fuzzy, they're faint, they're at the limit of your vision. So that's still, to me, there's a visceral reaction to seeing galaxies millions of light years away with just your eyeball. But for the visual spectacle, you need a camera. So there's a lot of appeal in these smart electronic telescopes that do all the work for you. They align themselves. You push a button, and they track, and they take pictures, and they can take long exposures in many cases, and see, a lot of galaxies and nebulae, a lot of dim objects in color. So there's a lot of appeal there. It takes out the learning curve to a large extent, and it opens up the ability to see these objects in ways that you would expect, in ways that are comparable to what you actually see in pictures. Because you are taking pictures, essentially, and you're looking at a screen one way or the other. Hang on a second. But here's the thing. Whatever you do with that electronic telescope, when you buy it, what you get is what you get. And the camera that's in it is pretty much going to be permanent. I haven't seen one with a modular camera that's designed to swap out for a better camera in the future. Now, the Beaver Lab scope, ironically, that one is a modular camera. You take the camera off to charge it and everything. Now, it's hard to call that thing a smart scope. It doesn't even have a motor. It's just you move it by hand, and it can only see the very brightest things, like the moon. But in principle, the camera comes off that scope, and typically with these electronic scopes, the camera's integrated, and that's the spec it is on the day that you buy it. That's the spec it's going to be on the day that you stop using it. And that can be, somewhat limiting. I've used a wide variety of cameras on my scopes over the years, and the camera I'm using tonight for Saturn here is not the same camera that I'm using when I want to shoot a galaxy or a nebula. It's a totally different camera, totally different setup, with a focal reducer instead of a Barlow lens, totally different focal length. And I can do that with the same scope. You can't do that with one of these smart scopes. You are limiting yourself to the specifications of the scope as it was built. And the way it was built with an integrated camera, you can digitally zoom, sure, but you're not going to be able to, say, go to extreme focal lengths where we're seeing Saturn like this tonight, at extreme focal lengths. It's not really, these scopes are generally not set up for that. Can you take a short exposure and see the rings of Saturn around Saturn? Probably, yes. But we're talking a tiny, tiny image of Saturn. These scopes are generally not that big optically either, so they don't have the optical resolution. The resolution in terms of angular resolution the scope can theoretically achieve is determined by the diameter of the optic. So this is a scope with an 11-inch diameter tonight. Your typical unistellar type scope, it's going to have a lens, a refractor design that is a couple inches, maybe a few inches across. Nothing like this. And that's fine for especially wide field, deep space work. A lot of guys with scopes like this or really high-end equipment will take a relatively small refractor and stick it on a equatorial mount and shoot deep space all night long, and produce these beautiful images. If you want to see, for example, the Andromeda Galaxy in all of its glory in a single shot without having to stitch a whole bunch of pictures in a mosaic, you're going to be doing it with a wide-angle, relatively small lens. But that particular lens, that particular telescope, is not going to be best suited for high magnification up-close planetary photography, for example. With this scope here, I could have a high-quality refractor riding piggyback on top of it and use the same mount, and reuse all the same mounting equipment, all the same computers and drive system, and shoot with a totally different camera, with a totally different, refractor riding piggyback, and then the next night use the same mount, the same scope, and go shoot a rocket launch, or a satellite, or a planet, or the moon. So, I guess the point I'm driving home here is there is flexibility that is naturally lost, and there's no escaping it with a smart scope, with a scope that is one of these turn it on and forget about it type deals that is got an integrated camera, an integrated optics, and you really can't change it. But the flip side of that coin is that it's simple. It's very easy to use. It's designed for beginners. So there's a lot of appeal in that, obviously. And, as much as I knock these things, as much as I sort of give you guys the bad side of that coin from my perspective, and saying, I wouldn't necessarily want one of these things, it's just not appealing for me. I'd rather get hands-on with the equipment, and pick which camera I'm going to put on the scope, and choose whether I'm going to use a focal reducer or not, depending on the target, etc., and really get into the details of it, and just setting up the equipment and choosing how I'm going to set up the equipment that night. Like, that's appealing to me. I want to be able to do all that. I understand, not everyone wants to fiddle with that. Some people just want to be able to take a scope out and spend an hour looking at the sky, take some pictures, and be able to share it on social media, and then go home. Go inside and be done. Here I am. When I set up the scope, I tend to have it out here for hours on end, and I'll be shooting a planet like this, or shooting a galaxy for hours, and it'll take me an hour or two to set up and an hour to tear down. Whole different process and different time commitment to even be able to use it, which means I don't necessarily even get to use it as frequently as I might like sometimes. But I like that hands-on. I like that level of fidelity in being able to decide how I'm going to shoot, what I'm going to shoot, etc. So, it depends on what you're looking to get out of it. But I still feel like if you're going to be spending that much money on it, there's a lot of options you should consider first. But they come with a potentially steeper learning curve, but I don't want that to scare people off, because I think the learning curve itself can be fun. Learning how to read star charts, learning how to identify constellations and the major stars of those constellations, I think is a useful skill. I can look up in the night sky and I can identify most of the brightest stars just by memory and be able to locate those constellations. I think that's a valuable skill, and I'd hate to see that lost over the years in the hobby, when people migrate to just their first scope being a smart scope and it does everything for them, and they don't really have to know how to navigate the sky themselves. But I guess that's like saying I wish people knew how to read paper maps. Is it really that valuable a skill once technology has supplanted the need for it? I don't know. Obviously, if you're someone who's going to be a professional astronomer, you probably do need to know these things, and it probably is important to hone that skill. But for an amateur like me, is it actually important? I don't know. I guess that's a debate we can have, but yeah, I feel smart scopes are kind of cheating. It is. You don't have to learn anything. You just turn it on and it does all the work for you. But what I'd like to know from people who, have these things, do you find that rewarding over the long term? Like, to me, it's like when you get on that learning curve and you learn how to use a conventional telescope and start to get good with it and able to take pictures and video and whatever you want to do with it, whether it's planetary imaging or deep space imaging or just even visual astronomy, there's a sense of pride in earning that skill, I think, and it keeps you coming back for more and keeps you wanting to push the envelope and see how much more you can do. Is there that same, maybe it's, maybe it takes on a different facet if you have a smart scope. Maybe instead of developing skill, you're just getting enjoyment out of it, just the simplicity of being able to set it up, turn it on, and go. But me personally, I don't know that would keep me coming back for more. It's like, okay, but there's no challenge in it. To me, the challenge is part of the fun. But I'm sure it's different for everyone. Again, I would just encourage you, before you pull the trigger on a smart scope, consider your other options as well. And if that's the way you want to go, that's fine. I'm not going to say you're, I'm not going to say you're a noob or, try insult people for doing that. I know people who are actually quite knowledgeable in astronomy who have a smart scope and swear by it and love it. It's great, whatever gets you out at night and gets you looking at the stars. That's what's important, right? But I just don't see the long-term appeal for me, and I would hate to sink that kind of money into a product and barely get any use out of it over the long term and then just stop using it altogether. Like that would be unfortunate. Yeah, the 11-inch scope, it's a big behemoth. And I got to have the time to use it. I've got to have the good weather to use it. Like, I can't because it takes an hour to set up and an hour to tear down. I can't risk if there's any chance that it's going to rain over the course of the night. Like, I don't like to take any risks with it. So there's certainly things that would keep me inside that I might take more risk in terms of just quickly being able to set up, quickly being able to carry it back inside if the weather starts to turn. I guess there's advantages there. But what keeps me coming back is knowing, like, I can always change out the camera, I can change out the Barlow, whatever. I can keep iterating the setup to try to see what else I can capture. Try new filters. Maybe one day I'll get a different planetary camera and try to do some Venus imaging with an infrared filter to try to get more cloud structure and detail. Like, that would be cool. I would enjoy doing something like that sometime. With the LX200, I've used a wide variety of cameras over the years, and progressively better cameras, and have dialed that sucker in where I can take decent astrophotos with it, deep space work, that, is way better than what I was trying to do with it 20 years ago. And I've had that scope for, well, just about 20 years now, so that's the thing. If I had a smart scope, would I still be using it 20 years from now? I don't know. I don't think I would, but that's just me, because I like iterating the optical train, So anyway, you got me on my soapbox there with that one. Sorry. Now, I know someone asked me if I've seen anything I can't identify. Have I ever seen an object I could not identify? Well, sure. Sometimes a satellite. Sometimes depends on how much research I want to put into it. Sky Safari's satellite database is far from comprehensive. It's got a pretty thorough database. I mean, it's pretty well populated, but it's not complete. So sometimes I'll be imaging something and a satellite will pass through, and I'll try to look up which satellite it is. Sometimes I don't come up with an answer. And if I want to, if I feel motivated enough, I can throw more computational power at that question. I can do some astrometry on it, and then I can pull the exact coordinates where the object was and the time that it flew through those coordinates, and then I can pass that into a different program that will search through all the orbital elements that I have access to see if there's a match. And if there's still not a match, then I can go further and I can find sources, amateur sources of classified satellite orbital elements that are not published by the government. Things that we as amateurs aren't technically supposed to know, but we do know are up there. And some amateurs do a really good job of tracking those classified satellites. Like, that's their hobby for them, is tracking these classified satellites and keeping tabs on their orbits. So, you know, I can try that kind of thing and throw those orbital elements into the mix and see if it's a match for a classified satellite. And, you know, sometimes it is. But then other times it still doesn't come up with a match. And so then it's a true unidentified object. What is it? Could be space junk. Could be a classified satellite that the amateurs haven't cataloged lately. There's still a lot of answers that it could be before you get to, say, extraterrestrials. But yes, to answer your question, yes, there are objects I've encountered over the years that if I put all the computational power I can at it, don't necessarily yield a known answer. That's not to say there isn't an answer. And that's not to say that it means it's, you know, a UFO in the little green men sense. There are known units. There are objects that amateurs know of and know their orbits. They're just orbiting Earth. They're not doing anything interesting, but they don't know which satellite it is. They don't know which classified satellite potentially it is. Could be a large piece of debris in some cases, off of a satellite that has broken apart. But yeah, I hope that answers your question. Then, of course, there was the time, if I want to talk about this, there was the time that I was filming a partial solar eclipse and something flew in front of the sun that I couldn't identify. Freaked me out, or I did not expect that. I mean, I was live streaming it. Came to the conclusion later that it was probably party balloons. I was looking over a bay, and on the opposite side of that bay was a barrier island where there's plenty of restaurants, resorts, condos, all kinds of stuff. And somebody was probably throwing a party and probably let off some balloons, and those balloons were tied together and flew in front of the sun. But it did look weird at the time. Doing the math on it, its angular size was consistent with it being a balloon at that distance, the distance of the barrier island. And other people, and here's the real key, like, I wasn't the only one watching that solar eclipse. There were plenty of other observers all over the world watching it, well, at least in the United States, and none of them saw anything over the sun, so it obviously wasn't some sort of, you know, alien ship near the sun or anything like that. It had to be local. It had to be relatively close to me, which starts to limit what it could be. And if it was close enough that it was at the same distance as the barrier island, it would have been an object only 12 to 16 inches in diameter. In other words, a balloon. But at the time, I didn't know what it was. Oh, any comets? Ah, yes, there is. There are a couple. Let's see. Yeah, that's the one I was trying to think of. C2023 P1 Nishimura. Sorry if I butchered the name. This is a relatively bright comet that's coming through right now, and might reach naked eye brightness. So that's one I would definitely like to photograph soon. So, yeah, I'm not sure if, not sure how long Nishimura will be visible from the northern hemisphere. I should probably get on that one. According to arif.net, it's expected to fade out rapidly after brightening. It'll be unobservable in September. It's going to approach the sun down to 0.22 astronomical units in mid-September. But it'll be observable again in October in the southern hemisphere, which is unfortunate for us northerners. But the one I'm really waiting on, which isn't for a while, is my comet, 414P stereo. Technically it's in the sky right now, but it's so far away and so dim that it's unobservable. But in a couple years, when it comes back around Earth again, it's not going to make a very good pass, but hopefully enough of a pass that it'll be observable. So I'm definitely going to make an attempt at that next chance I get. Yeah, there's some haze. I'm noticing the seeing is not as good as it was earlier in the evening, unfortunately. Getting some haziness coming over Saturn occasionally. You can see Saturn will suddenly get a bit blurrier, and then it'll steady. It'll get steady again for a bit, but it's so intermittent that it's making some real bad frames for stacking. If I were to try to stack the image right now, it would not come out as well as the clips I already recorded earlier, actually. Is it visible with the naked eye? Mine won't be. No, my comet will definitely not be visible with the naked eye. It will require optical aid to see. Hopefully the 11-inch scope here will be big enough to do the job when it comes back around again. So stand by, guys. I'll be back in just a minute. Heat shield, what the heck program are you using that's telling you that my comet's at magnitude 0? I wish it was that bright. SlickX says, can you tell me to just buy a telescope with mount instead of looking at bits that I could put together? Well, I mean, again, it's going to get me up on my soapbox again, but it depends on what you want to get out of it. The scopes I buy tend to already come with their mount, like the NexStar here, the 11-inch NexStar. It already was on this altitude azimuth mount that I've got, the NexStar mount. And for what I need it for, that's ideal. When I track rockets, I don't want to be using an equatorial mount. That doesn't make much sense for that application. It makes much more sense to film it from an altitude azimuth way, which is how people expect to see the launch. So I need that flexibility. Even with the LX200, that's what I did, is I had that on an altitude azimuth mount for tracking rockets and satellites, and then I'd switch to an equatorial mount for shooting deep space work. So you can get ready-made telescopes that are on a mount, like an NexStar or an LX200, and that'll work fine for some applications. If you want to do deep space work, though, if you want to do real serious deep space astrophotography, then yeah, you're putting together bits. You're getting a high-end German equatorial mount, and you're choosing which telescope to put on it. But depends on what you want to do with it. You know, if you just want to do visual observing and maybe occasionally dabble in some degree of photography, then yeah, an altitude azimuth mount with a telescope already mounted on it, that might be fine. They even make Dobsonians that have drive systems built into them as a potential option. They tend to be not necessarily as accurate as others, but good enough, you know, for some simple visual observing and tracking, and maybe some planetary imaging. Looking at NexStar, just need to see planets and rockets. Well, then that's perfect. That's perfect. NexStar it is then. I mean, that'll do nicely. I mean, I like my little 4-inch NexStar. It's a nice little scope. Go full nerd and build a telescope from scratch, tube mirrors and all, yeah. Yeah, and I had someone reach out to me today about putting together a scope to track rocket launches and stuff. I need to write back to them. If you're in the chat, I got your message, and I will write you back later. Apologies, I've just been out of the office today. I've been away from the house today until now, when joining Redstream, and then dinner, and then this. So just been busy, but I will get back to you later on my suggestions on a setup for you. Yeah, as you say, Andrew, like, grinding your own mirror, it's technically not that difficult. It's just requires a certain degree of diligence and care in the work. I mean, it does require some care in the work, but mostly time, right, and space to do it. So, one of these days, I might try my hand at it, but I don't know that I have the patience for it, to be honest. For the size of mirror I'd want to make. Like, it's real easy to get aperture fever when the materials cost is not that high. What's my thought about putting a hyperstar in the telescope? Maybe I'm wrong. Turning your scope into a cheaper RASA, lower f-stop with the eye viewer. Yes, I would love to get a hyperstar. They are not cheap. They are a couple $1,000 for hyperstar for the scope, at least $1,500, I think. So not a cheap investment, and also not a silver bullet. It's a good bullet, though, and I think if I had it on a wedge and I had a hyperstar on it, like, I could get some good work done on it. Like, I could get some good shots with it. Part of me even wants to see if I could get a hyperstar for the 2024 eclipse. Now, you can't put a solar filter with a hyperstar that I know of, but the idea would be have it on standby and then move it up to the sun and take a picture of the totally eclipsed sun with the hyperstar. Oh, I think that would be beautiful. I think that would work. I don't know. Maybe I'm wrong. I think that would work great. But that's a lot of money for, a 2-minute shot. I want a Daystar Quark, but that would probably need a new scope too. Oh yes, I want a Quark as well. I think that would be great. I don't know if... Yeah, I wouldn't try it with the NexStar 4. I wouldn't, because you're bouncing around the light inside the tube, and you might be overheating things. You very well might. Not to mention, I forget what the maximum aperture size is on the Quark. So, for those who don't know, the Quark is a solar eyepiece. Essentially, it's a hydrogen alpha eyepiece. And I've always warned people over the years, avoid eyepiece solar filters. They're dangerous. Don't do it. The Quark is a high-quality product that's designed to be used as such, but it does have its limitations. It does have a certain size scope it wants to be used with, and nothing larger. And also, if you have a catadioptric, if you have a telescope that folds the light inside of itself, bouncing around the sunlight inside your tube, generally a bad idea. You need a barrel to walk around to grind a telescope mirror. Yeah. And as Andrew says, you could just buy the mirrors. Yeah, it's always possible. In fact, sometimes amateurs will sell the mirrors that they have ground themselves if they, weren't entirely happy with the result, or they decided to go with a different size. Like, I've seen people sell their mirrors. Only use welding the glass to look at the sun. I mean, that is one option. There are other safe options, but you need to know what you're doing. Don't try it if you don't know what you're doing, and I mean really know what you're doing. Thousand Oaks, I use a Thousand Oaks filter for my telescope for my 8-inch. I really like the Thousand Oaks filter, but it is delicate, and you need to be mindful of that. There are some solar filters that are specifically designed for photography, that are designed to let in too much light to be safe for your eyeballs, so be careful of that. That means if you're using an SLR, that's not necessarily safe. If you're using a solar filter type that is specific for photography, Thousand Oaks made those. I don't know if they still do. I haven't looked on their catalog lately. But they made solar filters that were specific for photography, that were designed to let in more light than your eyeball is supposed to receive, because it makes it easier for the camera to use a really fast exposure and beat the atmospheric seeing. So you really need to know what you're doing with anything to do with solar observing. But they do make solar scopes that are specifically designed to be safe for use as solar scopes, like Coronado, the PST. I had a PST at one point. Lunt. So yeah, there's some options out there for safe solar telescopes that have integrated filters that are only ever designed to be used as solar telescopes. They're not normal telescopes. They can only be used with the sun. Put a tiny drop of water on your phone, you can see the individual pixels. Could this kind of lens work for a telescope? Well, it's funny you mentioned that. It reminds me of stories of very old historic telescope designs that were basically mercury. So mercury, of course, is highly reflective, and they would put mercury in a dish, essentially, and use it as a zenith telescope that is designed to see at the zenith straight above. So historically, that idea has kind of been used, but maybe not in the way that you thought. Thought I burned out my camera a while back. I think I was looking at the moon. Pointed the scope up in the morning, and I thought to put the dust cap on. Got distracted and didn't look at it until the sun was overhead again. Luckily, the sun hadn't lined up perfectly with the scope yet by the time I caught it. Whew, yeah. Well, I'm glad you caught that. Yeah, I gotta be careful of that. Yeah, spinning mercury mirrors. I forgot about the spinning part. Very important. You got to spin the mercury to get it to form the parabola shape or whatever, to turn it into a mirror. Yeah, that's what I was referring to there, Mandelbrot. Very good. Yeah, remember, mercury is poisonous. Very good point. So don't try that at home. Spinning mercury mirrors sounds like it has an attack damage value on a D&D campaign. Yeah, it does, doesn't it? Okay, I tried to tweak up the focus one more time just to be good. We're right about near the meridian right now, so Mercury. You got me saying Mercury. Saturn is at its highest point in the sky during this opposition tonight, so I'm going to go ahead and record one more video clip for stacking. Recording on the camera for, maximum quality here. I'll stay with the pinhole solar projector. I mean, yeah, that's always safe. As long as you're using it right. I think when Ryan is around, I'm going to do a "Is Beetlejuice Exploding Yet?" stream. Yeah. I mean, sure, go for it. Thanks, Stealth Mode. See you next time. Easy to spot the dead pixels as the camera jogs, so Saturn moves around, but the pixels don't. Exactly, yeah. Ah, gosh, that seeing is deteriorating again. I can just tell it's like not as sharp as it was earlier, which is crazy. Conditions have changed. Well, it's almost... Well, it's after 1:30 already, so... Tell you what, before I wrap up the stream tonight, let's point it over to Jupiter real quick and just take a look at Jupiter real quick. That's not half bad. I mean, it's not as sharp as Saturn, but it's not bad. Now, the moon down and to the right of Jupiter there, that is Io right now. You can really see the atmospheric turbulence rippling through the planet there, though, can't you? Yeah, those stripes are the cloud bands of Jupiter. Alright, folks, well, that's going to about do it for me for tonight. I'm going to have to tear down the scope here and get a little bit of sleep. But, hope you guys have enjoyed it. I certainly enjoyed bringing it to you all. Got to see Saturn, we got to see the moon for a bit, and now we finally get to wrap up taking a quick look at Jupiter as it's coming up. The red spot would definitely be visible if it were on the side facing us right now, but as you can see, it is not. The orientation is altitude azimuth, but it's also inverted because of the telescope, so up is actually down in the image. And by up, I mean up in the altitude azimuth coordinate system. Alright, well that's going to do it for me, so thanks for watching, and until next time, clear skies.